Good morning, everybody, and thank you to Morena in particular for inviting me to come and speak this morning. I've had a head cold all week, so if I sound a bit weird, I normally sound weird anyway, but this is a different version of it. So, sustainable building. The question mark. I had a funny week because I had a head cold. Been contemplating a lot of the deep things behind what we do, why we do things, and hence why the question mark, which should hopefully become apparent as we go through what I'm going to talk about now. Firstly, just short blurb, Envirotecture. We are an architecture and building physics consultancy firm. We are mostly architects and we design lots of different types of buildings, and these high performance ones are part of that. We know that we're in a bit of a series of crises at the moment of various types, whether it be planetary crises, affordability crises, lots of different versions. And that heavily shapes the work that we do and the way that we approach things. So today is a lot about how we do things, but it's also a lot about how we believe things should be done. And we very much take a view of trying to, I guess, lead by example. And we know that we, as a relatively small group of individuals, can't fix everything ourselves, but we like to think that we can at least help in a big push in the right direction. And so this combination of building science and biophilic design, I won't talk too much about biophilic design. I'm going to get let Laura talk about that a little bit later on. But these things coming together into what we call a nature-aligned version of architecture. So that's a little bit about us. And I guess the other thing to say is that this really is a systems thinking kind of approach. And with the crises we currently face, you could argue that it's a lack of systems thinking that has gotten us to where we are, and that we need to sort of step back, view the whole picture in order to work out what it is that doesn't matter, what it is that doesn't get us to a more positive and sustainable, truly sustainable position in the world. So I was asked to talk a little bit about, I'll provide a bit of an industry overview and sort of big opportunities thing. I will be honest, I've struggled really hard with how to do that. So I've got a couple of slides that attempt to tick that box. And I guess the key thing is the construction industry as a whole is massive in this country. It's a contribution towards greenhouse gas emissions is huge. A contribution towards economic growth is huge. The number of people employed is huge. It's a really, really big part of our economy. And in some ways, that is the opportunity. In some ways, that is also the problem, because you can't, achieving massive change in something so big is inherently risky, complex, time consuming, and therefore it's going to take a while. In the context of housing, I guess some of the big things that are worth not losing sight of it, the vast majority of homes in Australia are built by the biggest companies, and they are gargantuanly large businesses on the whole, and therefore they operate very much from a business perspective. They operate within the rules that they are given, and they see those rules in terms of both being a minimum standard, but mostly also being a maximum standard as well. And so change at that scale is really what we need. That's incredibly hard to make. The graph on the right is energy use by sectors in the economy. And so the thing to bear in mind here is, like, residential looks fairly small, but your house has an impact on electricity generation, manufacturing, mining, transport, because housing touches absolutely everything. It turns out that housing is the entire basis of pretty much everything, because it turns out that nearly everybody lives in some form of housing. And for those who don't, that's a even bigger problem, which makes housing a really, really big problem. So the impacts of this sector, this is a very swift snapshot of all the things that housing does that isn't good. Basically, they're the negative impacts, would be the safest way to put it. Most people would be aware of these to varying degrees. And the pie chart is around the energy use of houses as a generalization. Obviously, that's going to change. The space heating's a big chunk, but that depends where you are. In Darwin, that would be different to Melbourne, to Byron, to wherever. But the point is that it's a big chunk of the pie in terms of, where the energy goes in the house. And so the other component of our housing stock is this lovely graphic, and it's relatively self-explanatory, but it's often ignored part of the discussion. So we build the largest houses in the world. Arguably, we build the cheapest houses in the world, if you measure that by per square meter, but that isn't what really translates into real world impacts. in terms of your mortgage, because it can be a very cheap house per square metre, but if there's 500 square metres of it, it still adds up to be a very large amount of money. And so does this need to change? The opportunities. So the opportunities are massive. The cheeky smiley face, I'm not one really for emojis, but this one deserved it. We are supposedly, according to our federal government, building 1.2 million homes in the next 5 years. Anyone who's paid attention knows that that won't happen. And there's many reasons for that, and they're not really worth going into, but we can talk about it later if you'd like. It is safe to say that we need to build more homes. Whether we need to build 1.2 is a whole other can of worms, but we do need more of them because our population is still growing at quite a rate. We also have, give or take, about 10 million existing homes. No one actually knows how many we have, probably somewhere between 10 and 11, but we have no way of knowing because we don't actually keep records. And so the graph on the right is my cheeky sort of analysis of where we're at the moment, which is we've got a whole bunch of homes that are currently in need of retrofit because they don't perform very well. And then we've got a whole bunch of new homes that we're in the middle of building, which are being built to the current standards, which are also not great. So they also need retrofitting. And therefore, the volume of market for retrofitting buildings is just going through the roof. It was already huge and it's just getting bigger and bigger. So if you're in the market of retrofitting homes, then you're going to have a great couple of decades. Not necessarily great for homeowners who are, especially people buying homes at the moment, who are getting things that they think are going to be good, but are going to be in a fair bit of trouble fairly soon. Now, all of this, or not all of this, but a lot of this is all around energy performance and health. Well, that's what health and health about the energy performance of buildings. We'll talk about why those things matter in a sec. But the key thing with a lot of stuff around sustainable buildings has always been around being less bad. And I've already flagged it. I'm not going to jump into that little rabbit hole, but housing isn't just about energy performance. Housing's really about people. And less bad is good. It's better than more bad. But really, we're trying to get to the place where buildings are actually a positive, a good outcome, a good thing. And I'm not saying that's easy, but again, Laura will get to talk about that part of the fun stuff. Why? We really try to answer, and we do this at a project level, but in the big picture sense. Why do we build anything at all? Why bother? It's quite simple in many ways. It's because we like to think that it's better to be indoors than outdoors. And there's a reason that we don't still live in caves, under tarps, in tents, although there's an argument that Australian homes are just wooden tents. Yeah, exactly. And yet everyone sort of agrees. And that's really quite problematic because we've come to generally as a society accept that, which is really quite scary. But these, for me, underpin the reasons why. Like, it is about health, is about comfort. You can't be healthy if you're not comfortable. It's hard to be healthy if your house is 7 degrees when you wake up in the morning. We do want to be connected to nature. It's really hard to quantify these things, but we know that people who are better connected to nature have better health outcomes and generally feel better. Resilience. Resilience is just a massive, mostly undiscussed topic, certainly in the wider mainstream media, about how buildings will perform in a changing climate. Because we haven't really wanted to acknowledge the changing climate too much, we haven't really talked about what happens next. And yet we're building buildings that are going to live in that climate for decades to come. So all of these factors are reasons why we build. We want these buildings to be able to protect us and to survive and to be havens and healthy places as the world becomes probably more challenging, certainly more challenging at certain points in time. There'll be other parts where it's just lovely and nice as it is. So there's a whole bunch of other reasons people build, which are, status, financial incentives, like the tax system's incredibly skewed to put all your money into a house rather than anything else that arguably would be more productive. But, these are the big ones. This is the why we would bother to build, or why we do seem to build as a nation. So if we accept that we're going to build, and obviously there's an argument for not, and just go, nah, there's enough houses, they're just not used very well, something like there's an average of 1.5 empty bedrooms per house across the country. Therefore, just make people share. Arguably, that would solve the housing crisis, but it's unlikely to happen, it would seem, because we're not a communist state. So if we're going to build, what should we build? So this is the part where we talk about, I guess, the underpinning principles behind what we're going to build, or what we believe should be built. So we take, and we, as with my Envirotecture hat on, but broadly, if we're trying to build buildings that are set up for the future, we really want to be taking what we call a fabric-first approach. And you can describe that basically as this: insulating the indoor climate from the outdoor climate. And the when appropriate in brackets is very much because there are large chunks of the year, depending on where you are in the country, where outdoors is absolutely divine and living outdoors would be okay. It might only be between 10 and 3 on a sunny Sunday afternoon. And then from 4 o'clock onwards, it could get really cold. You want to close your house up again. That's fine. But it's important to acknowledge that there's a whole bunch of times when nature will deliver for you and your home without any intervention whatsoever. But there's a large chunk of the year, or the days, or the months, or the seasons when it doesn't. And so it's really important to be able to have that connection to outside when it's sensible, when it feels nice, when it's actually a positive experience, as opposed to just being permanently connected to outdoors when it's damn cold, windy, wet, and miserable. This is an ad from the Passive House Network, which is a North American organization that promotes passive house standards. They've been putting these, they've got a whole series of these. They're very clever. And been putting these out for about a year or so now, maybe 18 months. This came after, unsurprisingly, the massive fires through LA, but also with a lot of the other bushfire events, or wildfire events as they call them, that have been happening in the States. And the idea of this insulation of the outside and inside and being able to be separated becomes incredibly important during these bushfire events. There's great Australian research on what happened during the Black Summer bushfires with houses that were airtight versus houses that weren't. There's a lovely article in Renew magazine or Sanctuary, I forget which magazine it was in. But anyway, all talking about that. I can give you a link if you want. But the importance of having an airtight house, or a smoke tight, as the Americans are choosing to call it, during significant outdoor pollution events is really important. And obviously the bushfires were a very big, very scary thing and very hard to avoid. But these same principles apply if you have it who's got a fairly terrible, inefficient wood stove bellowing out smoke at 4 o'clock in the afternoon, then you've effectively got the same pollution problem indoors as you have in the middle of a bushfire event. It's just somewhat more localized. Not necessarily much you can do about that. No one's keen to ban wood burning stoves at the moment for whatever reason. And so smoke tight buildings, fabric first buildings are one of the solutions to that. So in terms of what to build, we and various other people have decided to build to a standard. And this standard has some definitions, and we put it there. So a building that sits between 20 and 25 degrees inside all year round, regardless of what's going on outside, every room in that building, not just your living room or your bedroom, but every single room. Humidity that sits within a sensible range where you won't get mold beginning to form, and also where your hands won't dry out. No cold spots, which is mostly around mold not forming. 100% door filtered air. We used to use the term fresh air, but then realized, well, it depends what's outside as to whether it's fresh. So filtered being the key part, and the no condensation and the no mold. Now, it turns out that those definitions, we didn't make those up ourselves because we think we're clever, but we're not that clever. And these are the headline metrics really that sit within what is known as the Passive House Standard, which originates out of Germany. And I will talk about that in a moment. The other component of what to build is quality. I would argue quite vehemently, and for days if you'd let me, that the main crux of our housing crisis in Australia is actually a crisis of quality. Whether it's apartment buildings that may or may not fall down with mascot towers, apartment buildings that catch fire, as in La Crosse in Melbourne, but we have a quality problem. Whether it's your bathroom that leaks, or the gap between your window and the wall you could stick a finger in through. It doesn't really matter, but it's fairly hard to argue that we have a quality building stock. And so what does quality bring? Apart from, what you'd like to think is the initial benchmark of keeping the rain out, which again is not always done, it's really around the warm and cool, because they're the ways they help. And this is a graph at a friend's house in Canberra, an old graph. But this is a house in Canberra, no heating apart from a tail rail and a bathroom, and they're 12 months of temperature data. So it just sits in the right place all year by itself because of how it's built, because it's built to a standard, and most importantly, because of the quality of construction that has occurred. And the performance gap mentioned up there, for those of you who haven't heard the term. So all homes in Australia, all new homes are designed to meet a national standard normally the NATER standard, National Home Energy Rating Scheme standard, and it's got a bunch of star ratings to it and all that sort of stuff. They have that tells you theoretically what your building will, how it will perform, how much energy it will use to stay warm or cool. And the performance gap is how everybody refers to the difference between what it says and what the building does. And depending on how things are measured, sometimes there's no performance gap. Normally there is one. Normally it's bigger than 50%. And so one of the biggest problems we currently face due to, in my view, the quality issue is that what you think you're going to get and what you get are wildly different. So I cheekily refer to this as, when you do the quality version, I refer to this as getting what you paid for, which of course is a polite way of saying that most people don't, which is sad in many ways. So if that's what we should be doing, there's a logical question about how to make. So in our work and the Passive House Standard generally, there are acknowledged to be these 5 building principles. Most of these may or may not be familiar with them relatively. So, appropriate levels of insulation. So, what does that mean? Well, it depends where you are. It depends on your building type and shape. So, the answer to that question is not necessarily simple, but with the bank having, so in the Highlands, for example, you would want to insulate under your concrete slab if you had a concrete slab, because you don't want to lose heat to the ground in winter. That's why if you have a concrete slab up here that is not insulated and you stand on it at this time of year, your feet will be cold because it's sucking heat from your body into the concrete. The amount of insulation in your walls will be greater than if you're in Sydney. It will be less than if you're in Darwin. So this is all about appropriate amounts of. We're aiming for airtight construction. And it can be scary. Airtight construction is fundamentally about control. We want to be able to control the flow of energy in and out of the building so we can accurately predict it. As soon as we can accurately predict how the building will perform, we can also optimize the building to make it as efficient from a cost perspective as possible. Because if it's airtight and predictable, we can tell you that if you were to remove a certain amount of insulation or add a certain, that it will get X% better or X% worse. And then you can decide whether that's good or bad value. The airtight construction is the part that makes all of this come together and see. You may have a niggling thing in the back of your head. We'll come to that. Minimizing thermal bridges. Thermal bridges are not particularly sexy, but they are, and they are literally the thermal bridge, thermal highway that goes from inside your building to outside. So that means that in winter, they will bring cold from outside to in, and in summer, they'll bring heat from outside to in. In summer, makes your house hotter. Turn on the aircon, she'll be right, maybe, but not particularly pleasant. In winter, cold surfaces inside your building generally mean condensation, which generally lead to mold, which lead to health issues, productivity, all the other things. They are incredibly important. What are they? In most buildings, it's steel, concrete, and aluminium. Steel and concrete are very useful building materials, and therefore we're not trying to say you shouldn't use them, although if you can minimize them, there's other reasons that would be good. But basically, when we use them, keep them inside the building or outside the building, not in and out at the same time. You can do things, and we've done them, where you have steel that goes from inside to outside, but they're painful and expensive and cost time and more money to do. And it's better to avoid it when you. Aluminium's probably the most interesting. Aluminium's a fantastic conductor of heat, which is exactly what you don't really want in a window system, for example, and yet it's how most of our windows are made. You can get thermally broken aluminium windows, which are basically 2 windows stuck together with a bit of plastic. They're fine too. But again, there's differences in what is thermally broken and what isn't. And there's a whole gulf of marketing stuff that seeks to confuse that issue for most people. We're trying to minimize these thermal bridges. It doesn't mean we need to eliminate them all. This is really back to knowing how our building is going to work. So we know that we've reduced the risk down so we're not going to get condensation. That's our biggest factor. We care about the energy impact of these things as well, but mostly it's around mitigating the condensation risk because we're really, really, really focusing on the building being healthy at the end. If it's not healthy, then it's effectively failed as a thing. Otherwise, it's better off out. Appropriate glazing and shading. So this is really around The types of windows, the types of glass, where they are, i.e. which way do they face? They face north, great, great. Sun in winter. Do they face south? That could be an awesome view, but pretty useless from getting heat gain into your building. Doesn't mean you don't have them. This is, again, it's around appropriate. It's about understanding the impact of the decisions you make about where your glazing is, how big it is. Do you really need a 3x3 square meter window in order to look at the view of your garden? Maybe you do. Maybe it's a great garden. Maybe it could be smaller. You can factor these things in. You can do whatever you like, but by modeling and understanding, you get to a point where you understand the implications of your decision. And the same goes for shading. You can shade windows with an eave. That can work really, really well, but there's a limit where that works, and sometimes you need things that move, blinds, awnings, whatever they may be. This is part of the process of design to optimize the building to get the best bang for your buck. Bang for your buck is common, of course, because that brings a conversation about value and what do you value. And value obviously has a financial component, but it's also got your other values in there, and they're much harder to replicate. The final piece of the 5 principles puzzle is mechanical ventilation with heat recovery. So for those of you that at air tightness that went, oh my God, how am I going to breathe? The answer is you'll be fine because it's not perfectly airtight, because almost nothing is. So you'll never die. However, without something like mechanical ventilation with heat recovery, you would end up fairly quickly in a mold-ridden, very damp house. And that's because you're human. And this is good, because if you weren't, then it'd be a weird event. But you breathe, you probably shower, you probably cook food, and you possibly hang your laundry inside at this time of year because it's too cold outside to dry at a sensible time frame. All of those things release moisture into your building. If there's no way to get rid of that moisture, it will just stay in your building because that's what it'll do. At some point, the surfaces of your building in relationship to the moisture in the air will eventually hit a point where condensation will start to form and mold will start to form on your walls, whatever, surfaces inside. This wonderful magical box basically delivers this outdoor filtered air into your building whilst throwing out the other air at the same time. So it's what we call a balance system, equal amounts in, equal amounts out. And it distributes it around the house. So it sucks air from wet places, bathrooms, kitchens, laundries, and it supplies air to places where you spend time. So living rooms, bedrooms, study, anywhere that's not wet. And so you've got this continual flow of air through your building. You won't feel it. It's very low volume. You're not supposed to feel it. If you feel it, then that's a design flaw. But what it does is it's getting that air out of the house with the moisture, bringing in the new air as they pass through this magical box. Then the heat from the outgoing air goes into the air that's coming in. And so in a rough example, if it's 0 outside and 20 inside, as those air streams pass, the air that ends up coming into your house will come in at maybe 18 degrees. So it's 2 degrees cooler than the air you threw away, but you've solved your moisture problem and your CO2 problem and all whatever other toxins exist within your house. So you've solved that problem for a 2-degree penalty. Your alternative option is to open the window, which may or may not work, depending on which window, which way it faces, and whether it's windy outside. And then your incoming air is 0 degrees. So the energy penalty you pay for ventilating your building is what it is, but its alternate, its plan B, is significantly worse. You also factor in, and part of the design process is to understand the loads within the building, so that includes the humans, but also the stuff. Everyone has stuff. You've at least got a fridge, and then TVs, electronic, all the other stuff within your building that consumes electricity also outputs heat. All of that stuff in a well-sealed, well-insulated box will help keep you warm. So they are the 5 principles of building, what are colloquially known as the 5 passive house principles. We talk about passive house having 8 principles. It's got these 3 principles of approach because those 5 things I've just spoken about, you could do all of those things, but without targets, metrics, a quality assurance scheme or a modelling process, you don't know whether you've got enough insulation, too much glass, not enough glass, enough shading, not enough shading, does the ventilation system right? So you need a way to bring these things together to give guaranteed outcome. So these 3 principles of approach have performance and comfort criteria. So the 20 to 25 degrees, the no cold spots for the mold, having those things is incredibly important. The modelling process, this one passive house package, try saying that after glasses are red, is the modeling system we use to actually understand the building, to see how it works. That's how we get to optimize the building, to be able to make something bigger or smaller, or put more insulation in, or take something. So that process facilitates understanding how it performs in those comfort criteria. And then the final part is quality assurance. So it's fairly safe to argue that the whole passive house building standard is a quality assurance scheme. It's dressed up as a building standard. It's dressed up as an energy standard. It's really about health and comfort, but it's really a giant QA scheme for building. And because of the process that we go through to get our buildings certified as being passive houses, so there's an independent third-party person who reviews all of our work, who reviews the builder's work, who looks at the blower door tests that are done at the end. All of these factors, all done independently of us, the builder, council, anyone else. That process means that all of these buildings, like I showed you with the graph from the house in Canberra, all of these buildings work pretty much exactly as they said they would. And that is back to the get what you pay for, but it's also the bit that allows us to optimize, to make sure that we don't use more resources or time or money or energy than we need to get the outcomes that we need. The QA part is a bit like the thermal bridges, the dullest of the bits, but the most important, because that's the part where it all comes together. So, can you do? Well, you can do new builds really relatively easily. I thought I'd throw a few pictures in. This is the house that's in the Highland. New builds. They're less complicated. They have less constraints than retrofitting build. However, you need to build everything from scratch, which is arguably what makes them easier, because you can plan every single detail before you. Obviously, that also means you need to pay for absolutely everything, because you start effectively with a blank slate. This is a house literally on the edge of a very big field, fairly unconstrained in a lot of ways. This is a small house on top of a garage in a very constrained place. The entire shape of this building is a product of basically boundary lines and council planning controls. That makes it tighter and harder. However, it's still completely possible. And so you can manipulate these things to do whatever you need. This is a house, this is down in Sydney. North is to the street. In many ways, that is not ideal. As you can see, even the windows that face the street are a little bit shaded. There's a way to make it work, because we understand the implications of the fact that it doesn't get great. You can see the shadow of the tree on the windows. All of those factors get rolled in early. And so this building still performs as well as a house in a field facing due north with nothing in the way, because of how it's been designed, because it responds to all those things through the process that we go through. And then retrofit. So start, there's 10-ish million homes that need to be retrofitted across the country. Definitely not showing the fact that that's a very big, but you can fix almost anything. This is orange, so colder, hotter, there in terms of extreme climates in New South Wales at least. This building geometrically has not changed. This is a genuine, nothing got bigger. We just took it apart and put it together. Like, it's still got a lot of its existing character. It's still got the kitchen that it had in it before, because the kitchen was only 3 years old and the client liked the kitchen, so why would you throw that away? We worked for it. And so you get a lot of stuff for free, because all the structure was already there. We didn't have to rebuild the structure. We just had to insulate it, line it, wrap all those kind of things. You can also, and we didn't do it here, you can also stage retrofit works as well. So there's ways to be able to do things over time. So just trying to flag ability. This is one of my favorite hobby horses. I won't dwell on it for too long, but if anybody wants to come and talk about it after, I'm very happy to jump in this rabbit hole. This is all around upfront carbon or whole life carbon. And the current way that things are structured massively incentivizes just throwing a whole bunch of solar panels on the roof of your house and then just air condition the bejesus out of it, and she'll be right. And depending on what you're measuring, that is, and certainly financially, that's the best thing you can do. If you care about health and comfort, it's an entirely different conversation. But money-wise, this thing wins hands down every time. This is a bunch of research we did actually on this. Looks the difference between, so it is the retrofit standard. Look the difference between the three options of just PV benefit or benefit the PV. See, what you can see is retrofitting the building and doing PV wins from a carbon perspective over time by the country mile. The blips upward are to do with allowances for replacing various bits of equipment. But the other thing that's really interesting is because if you only do the PV option, you end up putting on, depending on the climate and a few things, about twice as much solar. So you need a big enough building to put twice as much solar on. So your upfront carbon in additional solar is big. And also you need a much bigger air conditioning system because you're trying to fight, in this case, the orange climate in a crap building. And therefore, everything's got to be bigger and consume more power in order to be able to overcome the fact you didn't fix the building. So from a carbon perspective, if that's what you care about, then it's much better to retrofit the building. So if you were to retrofit the building, your first freak would be how much is this going to cost? And that's a fairly good thing to freak out about. I would recommend giving it a lot of thought. This is some work we did. We've done it twice, actually, but this graph is from about 2018. And we did a house in Sydney in Thornley. It was the first certified passive house in Sydney. And it was priced by multiple builders before it got built, which was annoying in many ways. But anyway, got a great outcome at the end. For each of those prices, we managed to pull apart how much of the building was to do with the performance of the building. And so by performance, what we're really referring to is the walls, roof, floor, insulation, air tightness, mechanical ventilation. So the things that make your building work in terms of health and comfort and energy efficiency. So it's not tiles, bathrooms, kitchen. It's not builder's margin. It's not scaffold. It's not painting. It turns out that somewhere about a third or quarter to a third of the cost of the building is to do with the performance of it. The rest of it is all those other things. You can't necessarily get away from all those other things, but what we learn from it and what we think is the important takeaway from it is that the cost of building well is not the problem. At the moment, the cost of building is a problem. It's become much more expensive than it was. It's never been particularly cheap, but the cost of building well is not the source of the issue. And as certain people in the media decide that they would like the building code to freeze and never change again, we think that's fairly short-sighted and dumb, to be honest, because it's about cost of building that's the issue. Cost of building well is not the source of the problem we currently. So, in what is now a blatant plug for one half of what we do, in order to try to have some more affordable solutions to the housing crisis, our Passive House Design and Construct venture is shortly going to relaunch itself, do a bunch of pre-designed things. This happens to be a granny flat because it's the first one we've actually finished. And basically, it's predicated on the fact that in a lot of cases, a pre-designed option really would work. Australians have a deep-seated desire to customize every home, and that is part of what makes building well a bit tricky. And so these are very much going to be here's a thing, you can buy this thing, this is what it looks like, it'll be a certified passive house. You can choose to buy this thing, yes or no. If anyone's next question is, could I just move a wall? Then the answer is, that's great. Come to Envirotecture, we'll custom design you anything you like. These things will be yes, no, very much a pre-designed, it's all locked in. This is why it can be cost effective. We've been down this road with a bunch of people over the years, but mostly other builders and prefab firms. And we know that the changes are the thing that make the things expensive. And so for a certain group of people, this is going to work. Whether it's a big group of people, we really, but we thought it was worth a crack. This is probably, I guess, manifesto for one of these are all the things we think are important. I used this slide a couple of months ago at a conference, and a very good mate of mine then spent 20 minutes arguing about the hierarchy of these things because he thought that there was a hierarchy to these, from top to bottom. He thought the one at the bottom should be at the top. I've since realized that there is no hierarchy in this because I did try to reorder them and then just got lost in a quagmire. So no hierarchy. They're all very important. We should do them all. And final slide is actually a really blatant plug because I realized the other day, we've got a site tour of a passive house that's under construction in Sydney, in Curl, so Northern Beaches, on August 29. If anybody would like to come, QR code, send you to a place, book tickets. It's free, but you do need to book tickets to be able to go. And if you'd like to, then please do that. with that note, I thank you for your attention.
Q&A.
Excellent.